Hello students. Today let us begin with new chapter linear programming of your 12th class. You have already studied linear inequalities and you have find the solution of these inequalities using graphical method in your 11th class. In linear programming chapter, we will study the application of linear inequalities in the problems which are related to optimization. Optimization means we can say maximization and minimization. And these problems are generally called linear programming problems. These problems are mainly used in the field of business, commerce, management, and many more. In business, we can take example like one person wants to start business. So उसका मोटिव क्या होगा? His motive will be कि जितना उसके पास रिसोर्सेज हैं उन रिसोर्सेज को वो कितना अच्छे से यूज करे और उसको उसमें जो प्रॉफिट हो वो मैक्सिमम हो और जो कॉस्ट हो वो मिनिमम हो. दैट इज द मोटिव of each and everyone who want to start business. So, the answer of all these questions will be given by linear programming. Linear programming is simply the problems of planning. You can say linear programming problems are the problems of planning. That how to invest and how to get maximum profit and minimum cost in the business. To understand these problems, let me start with one example. Example says, a dealer deals with two items, tables and chairs. He has rupees 50,000 to invest and has a space for at most 60 pieces. A table costs rupees 2,500 and a chair rupees 500. He estimates that from the sale of one table, he can make a profit of rupees 250 and that from the sale of one chair, a profit of rupees 75. He wants to know how many tables or chairs he should purchase so as to maximize his profit, assuming that he can sell all the items which he has purchased. So here in this example, it is clear that dealer is having only 50,000 rupees with him and he can store only 60 items. And now he wants that he get maximum profit. Let us take some cases which are possible for this problem. The first case, let us take, he purchased only chairs and no table. As the cost of one chair is rupees 500, so he can purchase 50,000 divided by 500, that is 100 chairs, but he is having space for 60 items only, so he is bound to purchase only 60 chairs. Now, as it is given that he can sell all the items which he purchased, and on one chair he is getting a profit of rupees 75. So his profit is 75 into 60, that is he is getting 4,500 rupees 4,500 as profit if he purchased only chairs and no tables. Now the case may be he purchased only tables and no chairs. So in this case, as the cost of one table is rupees 2,500 and the total amount he want to invest is 50,000. So therefore, number of tables he can purchase is 50,000 divided by 2,500. So therefore he can purchase only 20 tables. Now he is getting a profit of rupees 250 on one table. So therefore the profit he can make on this purchase will be equal to 20 into 250, that is 5,000 rupees. Let us take third case. He may also purchase 10 tables and 50 chairs. He can't purchase more than this because the capacity that he can store is maximum of 60 items. Now let us find the cost of these items. Clearly, the cost will be 10 into 2,500 plus 50 into 500, which is equal to 50,000. So he has invested the whole amount he is having, that is 50,000 rupees. Now let us find profit on this. So if we are talking about profit, then clearly on 10 tables the profit will be 10 into 250 plus 50 into 75, because 75 is the profit on one chair and 250 is the profit of on one table. So the profit that he is getting is 6250 rupees, 6250. So if we are discussing these three cases, we are finding out that in first case he is getting a profit of 4,500. In second case he is getting a profit of rupees 5,000. In third case he is getting a profit of rupees 6,250. So out of these three cases he is getting maximum profit on this case when he is purchasing 10 tables and 50 chairs. There may be more ways in which he can invest the amount. So one way is कि इस तरह से वो प्लानिंग करे और इस तरह से कैलकुलेशंस करके देखे कि कहाँ उसे मैक्सिमम प्रॉफिट होगा और वहां वो अपना इन्वेस्टमेंट करे. But it is very difficult to calculate the exact maximum profit by using this method. This is hit and trial method actually. But the exact solution if we need, if we want to find out, then linear programming will help us to find out the exact maximum profit, that how many items he should purchase so that he can have the maximum profit. So now let us try to frame this problem mathematically as we have done in case of linear inequalities in class 11. The first line is he has rupees 50,000 to invest, means he can invest a maximum of rupees 50,000, and he has invested this amount of 50,000 on two items. Let X and Y are the number of tables and chairs. So as per the question we are having, he is having space only for 60 items. He can store only 60 items. So we are having X and Y as the items, means tables and chairs. So one of the inequation that we are getting is X plus Y less than equal to 60, because the total items should not exceed 60, either less than 60 or is equal to 60. So this is one of the inequation. Second one that we have, from here the table cost rupees 2,500 and a chair rupees 500. So what does it mean? The cost of X tables will be 2,500X and cost of Y chairs will be 500Y, and the total cost of these two should not exceed 50,000, because he is having maximum 50,000 rupees with him which he want to invest. So the total amount should not exceed 50,000. Now the other two inequations are X greater than equal to 0 and Y greater than equal to 0. Why this is so? Because as x and y represent number of tables and chairs. So these two cannot be negative. Either these are some positive quantity or the 0 means he is not purchasing any one of the item. One thing more we are having in the question, and which is profit. That is, he can make a profit of rupees 250, and that from the sale of one chair a profit of rupees 75. So by selling one table he is earning a profit of 250, and by selling a chair he is earning a profit of rupees 75. So therefore the profit for X tables will be 250x, and on 75 chairs it is 75y, and the total profit is the addition of 2, and this can be written as z, and z is the function which is formed for the purpose that we need the maximum profit. So in whole we are getting 4 inequations, number 1, number 2, number 3 and number 4. In certain problems we may have more numbers of inequations as well, and this is the objective function. This is called objective function. Why objective function? Because our motive, our object is to maximize the profit, and after calculating the values of x and y graphically from these inequations, as you have done in your 11th class, and putting these values of x and y over here, we can calculate the profit amount. Now let me discuss some of the definitions which are very important to know in this chapter. The very first definition is optimization problem. So problems which involve finding maximum profit, minimum cost or minimum use of resources called optimization problem, and the problem that I have taken is the example of optimization problem. Linear programming problems is a special type of optimization problem. The difference is, in linear programming problems we are going to frame only linear inequations and equations. What is objective function? A linear function z is equal to ax plus by, where a and b are constant and x and y are variables, which has to be maximized or minimized. As in above example, z is equal to 250x plus 75y is the optimization function, or you can say objective function, and we will read it as z maximize here. If we need to minimize, means it is the problem of cost, then we will write it as z minimize. Next, you should know about decision variables. X and y are called decision variables because the values of x and y are going to tell the result, that how to invest the amount to get maximum profit and minimum cost. Next is constraints. The linear inequalities or equations on the variable of a linear programming problem are called constraints. In the above problem, we are getting 4 constraints, and these are like, this is number 1, this is number 2, this is number 3, and this is number 4. So these 4 are called constraints in linear programming problems. X and y are also called non-negative constraints, as I told you in the example, that these are deciding the number of items. So therefore these cannot be negative. So these are also called non-negative constraints. So these were all the definitions that you should know about linear programming problems. Now this is the time to know how to get the values of x and y by using graphical method. And this is not a new thing for you. You have already done in your 11th class when you have drawn the graph for the linear inequalities. And you know very well how to draw the graph for inequalities. So first of all, let me take all the constraints of the problem that I have taken in example one by one, and we'll draw the graph for all these. In our example, we got these 4 constraints and this z as the objective function. Now let us draw the graph of these constraints one by one. Let me take the very first. It is after taking common and cancellation, we are getting 5x plus y less than equal to 100. And there is no scope of any solution in second, third and fourth. So let us keep them as it is. Now, as you know, we'll make a table over here for x and y. If we put x is equal to 0, then y is 100. And if we put y is equal to 0, then x is 20. This is table number 1 for first constraints. Now let us take the second constraint. It is x plus y less than equal to 60. One thing more I want to mention over here, that the table that we are making is simply for 5x plus y is equal to 100. As you have studied in your 11th class, first of all we'll draw the table for equal to, then while drawing the graph we'll mention this less than sign. So similarly here I'll make the table for x plus y is equal to 60. This is a second constraints, and from second constraints we are getting table number 2. Here x, y. If we put x is 0, clearly y is 60, and if y is 0, x is 60. Now let us draw the graph for these two. As x greater than equal to 0 means x is equal to 0 and y is equal to 0 are simply, this is y-axis and this is x-axis. So there is no need to make table for these two. Now let us draw the graph for these values. Here I have taken y-axis and x-axis. On this, let me take the scale 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Similarly, let me take the scale on x-axis. Here I have taken one space as 10 units. So this is 10, 20, 30, 40 up to 100 I have taken. Now we need to plot the values of table 1. Table 1 says when x is equal to 0 we are having y 100, and when y 0 we are having x 20. So when x is equal to 0, y is 100. So let me plot the point. Clearly this is the point, x is equal to 0 and y 100. The second point, when y is 0, x is 20. So this is the second point, and you know very well, now we need to join these 2 points. So here I have joined the 2 points. Now the second one is x is 0 when y is 60. X is 0, y is 60. 1, 2, 3, 4, 5, 6. This is 60. And when y is 0, x is 60. 2, 3, 4, 5, 6. This is 60. Let me join these 2 points again. Here I have joined the 2 points. Now we need to draw x is equal to 0. Clearly it is y-axis and y is equal to 0 is x-axis. So we have drawn all the 4 constraints on the graph paper. Now we need to shade the region which will give us the solution region. As you know that for the first table which we are having is 5x plus y should less than equal to 100. And in 11th class you have studied that to know about which direction or in which direction the graph will be shaded. So for that you need to put x and y both are 0, means we'll check it at origin. So if we put x as 0 and y in 0, clearly it will give us 0 less than 100, which is true. So therefore the shading of first line will be towards the origin. So let me do the shading for it. So this is the reason that we are getting due to in equation 5x plus y less than equal to 20. Now the next inequation that we are having is x plus y is less than equal to 60. So clearly again if we put x as 0 and y is 0, 0 will be less than equal to 60, which is also a true statement. So therefore its shading will also be towards origin. So this is the shading which is corresponding to the inequation x plus y less than equal to 60. Now the third one we are having x greater than equal to 0. So clearly x greater than equal to 0 will be like this. It is x greater than equal to 0 and the next one is y greater than equal to 0. Clearly for y greater than equal to 0 we are having the shading as to this side. So now let us find out the common reason out of these four. So clearly the reason, let me name it as O, A, B, C. This is point B where the two lines are intersecting each other. So O, A, B, C is the reason where we are getting shading for all the colors, or you can say for all the constraints. This is green for x greater than equal to 0. This is gray for y greater than equal to 0. The red one for x plus y less than equal to 60. And the blue one is for 5x plus y less than equal to 20. So this is the reason which is called the feasible reason. So you should know the definition of feasible reason as well. So feasible reason is the common reason determined by all the constraints including non-negative constraints. यहाँ पर हमने x greater than equal to 0 और y greater than equal to 0 को भी include किया है. That's why we are saying it is the common reason obtained by all the obtained from all the constraints including non-negative constraints. And the points which are lying on this boundary and inside the boundary are called feasible solution. And the reason which is outside this feasible reason is called infeasible reason, and all the points which are lying outside this reason is called infeasible solution. Now let us use corner point method to find out the points at which we need to find out the profit which will be the maximum. So here point O is clearly 0, 0. So there is no need to use this point because we are getting only 0 from this. Second point A is having the coordinates as 20, 0. Point B is having the coordinates as, this is point B, and this is having the coordinates as 10 and 50. We are taking approximately over here because the exact points you will get when you will draw this graph on graph paper. Always use graph paper to draw the graph in exam or even when you are practicing the questions, because it will give you the exact location of the point. And the point C is clearly 0 and 60. So these are the points at which we need to calculate Z, means the optimization function. Here in this problem, the Z which we are having is 250x plus 75y. So let us put these three values one by one over here. So very first let me put A. A is 20 and 0. Clearly when we put x as 20 and y is 0, Z will be equal to 5000. Let me put second point, that is B, which is equal to 10 and 50. So clearly when we put 10 and 50 in Z, we are getting Z is equal to 6250, and the third point is C, which is equal to 0 and 60. So for this point we are getting Z is equal to 4500. So clearly the maximum value that we are getting out of the 3 is this one, 6250. So therefore he should purchase 10 tables and 50 chairs to get the maximum profit. In this way, he can utilize the space that he is having with him, that is the 60 items he can store. So maximum items he can store over there, as well as he is using the total amount over here that is with him, that is 50,000, and on this amount he is getting the maximum profit as well. So in this way, these problems helped a lot to find out the maximum or minimum values for the purpose of business, that is how to reduce the cost and maximize the profit. One thing more I would like to mention over here, that this feasible region may be bounded or unbounded sometimes. Maybe the feasible region is lying outside this boundary OA, BC. This may also happen. In that case also we'll take the points OA, BC as the corner points, and on these corner points we'll calculate the optimization. Now let me discuss two more types of problems, and these are manufacturing problem and diet problem. Let me take one by one. Let me start with diet problem. Is Reshma wishes to mix two types of food, P and Q, in such a way that the vitamin content of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. Food P goes to P 60 per kg and food Q goes to P 80 per kg. Food P contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, while food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Determine the minimum cost of the mixture. In this problem, the producer want to make two types of food, P and Q, and he want that these food should contain at least 8 units of vitamin A and 11 units of vitamin B in these foods. Now, cost of food P is given to you and cost of food Q is also given to you per kg. It is also given that how much amount food P and Q contain per kg of vitamin A and vitamin B. Now we need to find out minimum cost. So therefore this is the problem of minimization. So to start this problem, let us consider let X and Y kg of food P and Q are mixed. To simplify this problem, we can make a table like on one side let us take food P and food Q, and on another side let us take vitamin A and vitamin B. So here let us fill the table by using these contents. Food P contains 3 units per kg of vitamin A. So means 3 units per kg of vitamin A. This food P contains, and vitamin B is 5 units per kg. This the food P contains. Now food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. So this is the table, and next we can take from here that mixture contain at least 8 units of vitamin A and 11 units of vitamin B. So minimum amount, you can write here, minimum amount of vitamin A is at least 8 units of vitamin A. Minimum amount is 8 units over here and 11 units of vitamin B over here. Now next we can write cost. So food P goes to P 60 per kg. So we can write here here as cost. So it is 60 per kg is the cost of food P, and 80 per kg is the cost of food Q. Now, as we considered that X and Y kgs of the food P and Q are mixed. So therefore, we can make the inequations or the constraints as 3x plus 4y should greater than equal to 8. First of all, let us consider this thing. It is given that 1 kg of food P contains 3 units of vitamin A. So clearly, x kg of food P will contain 3x units of vitamin A, and similarly, it is given that food Q we are taking y kg, and 1 kg of food Q contains 4 units of vitamin A. That's why the content of vitamin A in food Q is 4y, and the minimum amount is 8 units. Means the total amount of vitamin A should not less than 8 units. So therefore it should be greater than or equal to 8. Similarly, the next constraint will be 5x plus 2y should greater than equal to 11. The same way, per kg 5 units food P contain, per kg 2 units food Q contains, and the minimum amount is 11 units. And we have x greater than equal to 0, y greater than equal to 0. These are the non-negative constraints. And now we need to minimize the cost. So therefore, our objective function will be z is equal to per kg cost is given 60 and 80 for food P and Q. So therefore, for x kg we are having 60x as the cost for food P and 80y as the cost of food Q. So the z we should write here minimize z. Minimize z is equal to 60x plus 80y. So here in the problem we are having 4 constraints: number 1, number 2, number 3 and number 4. Now in the same way we will draw the graph for all these 4 constraints. We will find out the feasible region and the solution points, or you can say the corner points, and then we will place these corner points over here in z, that is in objective function, that will help us find out that how much amount of food P and Q should be mixed to minimize the cost. Next, let me take manufacturing problem. It is a manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts. It takes 3 hours on machine A and 1 hour on machine B to produce a package of bolts. He earns a profit of rupees 17.50 per package on the nuts and rupees 7 per package for bolts. How many packages of each should be produced each day so as to maximize his profit if he operates his machine for at most 12 hours a day? So clearly it is the problem of maximization, because we need to maximize the profit. Here we need to calculate how many packages should be produced. Let X and Y packages of nuts and bolts are produced respectively each day. So X are the packets of nuts and Y are the packets of bolts, and these are produced each day. So to simplify the question or to make the constraints, let us make a table of, on one side let us take machine A, machine B, and on another side let us take nuts and bolts. It is given that 1 hour work of machine A and 3 hours on machine B to produce a package of nuts. Means to say, to produce nuts it takes 1 hour on machine and 3 hours on machine B for one packet. It is also given that it takes 3 hours on machine A and 1 hour on machine B to produce a package of boards. We can write 3 hours per package and 1 hour per package to produce boards on machine A and on machine B respectively. Further, it is written that he earns a profit of rupees 17.5 per package on nuts and rupees 7 per package on boards. So this can be written over here. Profit is 17.5 per package on nuts and rupees 7 per package on boards. Next, it is given that if he operates his machine for at most 12 hours a day, means maximum hours of working, maximum working hours we can write over here. It is 12 hours in each type of machine, for machine A as well as for machine B in a day. By using all these informations, we can have the inequations as x plus 3y should less than equal to 12. From here we are taking this thing. For one packet, 1 hour is taken. For one packet of board, 3 hours are taken. So for x packets of nuts, x hours will be taken, and for y packets of bolts, 3 y hours will be taken. And working hours for a machine should not exceed 12 hours. So therefore the total time taken on machine A for nuts and bolts should be less than equal to 12. Similarly, from this data we are having 3x plus y should less than equal to 12. And two more inequalities are x greater than equal to 0 and y greater than equal to 0. So here we are getting 4 constraints. These are constraints. Now we need to make objective function. So objective function is Z maximize, because we need to maximize the profit. So we'll write here Z maximize, and it is given that on one packet 17.5 rupees profit is there on nuts, that is 17.5 x for x nuts, and 7 rupees per package, it means 7 y means for y packages. So this is the Z maximize. Now by solving these 4 constraints graphically and obtaining the values of x and y, and by putting these values in Z, we can find out the maximum profit, that is how many packets of nuts and bolts should be manufactured so that the manufacturer can earn maximum profit. As you see, the problems based on linear programming are very simple. From the given data, you have to frame the inequations and objective function, and simply by using graphical method, you can find out the required result. I hope you can simplify all types of problems very easily, and for your all problems, I am always here with you.